Hello, everyone, and welcome back to one of the sessions of probability. Today, I want to introduce RStudio and how we are going to use that as a software to help us in large problems, so to speak. So, before we start, I want you, before watching this video, is to download R, which is a statistical language, so a computer language that is specifically made for statistics. So you can go online and just type, Google R language, or just R, and you will find a lot of places where you can download it. Once you download it and install it on your machine, be it Windows, Mac, or Linux, just go ahead and download RStudio. So after you install R, download RStudio. You can find it in, again, many places. Um, and once you install RStudio, just click on the icon of RStudio. Don't start R, start RStudio. It will, upload R with it. So they work together. Once you open, you will get a window that looks like that. The one that where the cursor is basically here where you write your script, meaning the program that you want to run. Okay, so that's the editor. At the bottom, there is the console. The console can work as a calculator. So if you have a one line thing, so you can say, for example, 2 plus 3, or you say 2 to the power of 3, 8, and so on and so forth. You can do any simple math. But if you want to write a program, so you would have like a for loop or a nested if statement, you cannot do it in the console. You have to write a program. Okay. And this program, you can save it. And R uses a specific directory. You can create your own directory, or you can use, say, the desktop or the documents or whatever you want. So the first thing I want you to do is, after you install that, is to go to Tools, click on Tools, and select Global Options. That's the easiest way to do it. Okay. Once you click on that, you can browse here and select whichever directory you want. I created a directory called data, and I stored here some of the stuff we were using in the course and other personal stuff. So pick whatever you want and say open. Okay. And once you say open, you can apply and say okay. That doesn't mean you are done. You have to quit and restart RStudio. Now, anything that you save, so now if I write something here and then I quit, it will ask me, do you want to save? If I say yes, it will store it in that directory you select. Here, every time you create a variable in the script and run the script, it would be stored here. So you would know, or if you open a file, sometimes I may have a file that contains large data. I cannot type all of that. So I upload it, it will show up here. And at the bottom here, you can use the help. If you have, I will talk about packages that you can install. The files that you have in your directory will show up here, so you can click on one and start it right away. Plots, if you are going to show, say, histogram or something, it will be stored here, or you can show it on the screen. We'll talk about all of this later, but today I wanted just as a simple introduction, and then after that, we'll see how we can use that um, to find, say, confidence interval or hypothesis testing. We can create our own, like when you solve the problem and find the, T alpha over 2 and degrees of freedom and whatever, you do it manually, or there are stuff that is already pre-made for you. Like what we did with the calculator. You say run a t-test, it asks you for, x bar, mu, s, and it will create it for you. So we'll do both because I want you to learn how to do it. It's so simple that we'll learn how to do that together. Before, so today, what I want to show you here is how we manipulate, or how do we use probability distributions. We learned about the binomial, the Poisson, the geometric as discrete, and then we did the exponential and the normal for continuous. So we'll see how we can use the RStudio to help us with those instead of looking in the tables like for chi-square, what we did before. So every okay, before we proceed, I'm not sure if it comes with RStudio or you have to download it. So I want you to click on packages. You see packages here? Um, on my RStudio, there are some that are selected and some that aren't, but I can select them later. Okay, and you can see here it says library boot, that for the bootstrap, but I usually don't use it. I create my own bootstrap file. But down there is stats. That's what we will need today. You see stats here? If you already have it, it may be selected already for you, or you select it. Just click on that. If you don't have it, which I doubt, but I don't know. If you don't have it, then you can click stats here. See, when I start to write ST, it will show everything that starts with ST. Now stats, if it's not selected, or if you write stats and nothing and stats doesn't show, you can click install and it will install it. Also, you can check to see if the most up to date by clicking update. So if I say update stats, well, it's already updated. So these are the four packages that are not updated on my machine. But if stats shows up here, you select it. Okay. And then click install updates. It will update it for you. Okay. Having said that, now we have the stats. Then we are going to look at some oh, by the way, you can clear this by clicking on the broom here. It will do that. Same thing for this guy. You can we'll see how we clear everything in the environment. So now every distribution comes with four functions. Okay, so let's take an example. Suppose I'm tossing a coin again, binomial. Okay, so binom, B-I-N-O-M, is the distribution, and you can use four things. You can find the probability mass function. Remember, we called it mass function for discrete and density function for continuous. But for R, all of them are D. D stands for density, but it will give you, for example, I want to say D, oops, I'm sorry. I say D binom. And once I open the parentheses, you see it asks me what number do you want? What is the size? Meaning the population. So meaning I'm going to run it how many times? And what is the probability of success? So suppose I want to toss a coin, let's say 4 times. What is the probability that I get 2 heads? How do I write that in R? Notice we know the answer. If you show the Pascal triangle and you go to the row of 4, you will see the numbers 1, 4, 6, 4, 1. Meaning it's a probability of 1 over 16, which is 2 to the 4th, of getting no heads or 4 heads. 4 over 16 to get 1 head. 6 over 16 to get 2 heads. So if I want 2 heads, RStudio should give me 6 over 16, or when you simplify it, it's 3/8, which is 0.375. Okay, so if I say, for example, 2, comma 4, comma 0.5, now you see the x is 2, the population size, meaning how many times I'm sorry, not the population size, the sample size. It means 4 times I'm tossing the coin, and the probability of success is 0.5. Now you can click, I don't know, in Windows, I think it's here we click, I have a Mac, so I click Command, Shift, and Enter. Or you can go to think, uh, is it in code or? Yeah, you can run selected lines. We only have one line, or run the whole thing. Okay, so in your machine, it will tell you how to do that. In Mac, you do the command Shift and Enter, and you can see here it tells you that if you want to find the probability of two heads in four trials and the probability is zero point 0.5 is 38 or 0.375. So d binom will give you the density or the mass function for binomial distribution. D poise would give you the Poisson. D exp would give you the exponential. D norm would give you the normal. D Weibel will give you the Weibel. And you can, look for help about the that stats, and you will get everything. So that's the first. The second one is the cumulative distribution or the probability. So we use P. So if I want to find the probability of getting up to two heads, meaning zero heads or one head or two heads, it will add all of them. Remember in the Pascal triangle, you have 1, 4, 6, 4, 1. So if I write P binom 2, 4.5, it will get the probability of 1, which is 1 over 16, plus 2, which is 4 over 16, plus 3, I'm sorry, plus 1, plus 2, which is 6 over 16, or a total of 11 over 16. 11 over 16, it will write it as a decimal. So it's what, 6875, I think? We'll see. P binom 2, 4.5. It tells you lower tail is true. Forget about that. Don't worry about that. Or the log, if it takes the logarithmic value. So I will go to code and run selected line. And you can see 0.6875. If I run the whole thing, it will run the 0.375 and then the 0.6875. That's the second one. The third one, we don't usually use it for discrete distribution. Why? That gives you the percentile. Notice that if I ask what is the median, for example, of this binomial distribution, so we use the Q to give you the inverse. Okay, so if I say Q binom, it will ask me for P, what probability, meaning what percentile. So for example, I want the fifth percentile, 50th, I'm sorry, 50th percentile, which is the median, okay? And I have 4 and zero point 0.5. And I'm going to run only this line. It tells me 2. Okay, now let me try a 30th percentile. So I'm going to go back and change that into 0.3 and run it. It says 1. So it really gives you, it doesn't give you just a value. This value is not correct because if you run the cumulative of 1, it will not be zero point 0.3. Or the cumulative of 2, we found that it was 6875, not zero point 0.5. But it tells you the 50th percentile is somewhere between 1 and 2. The 30th percentile is between 0 and 1. So it gives you the smallest number that exceeds that probability, because you cannot get exactly a number because this is discrete, not continuous. So usually we don't use the Q with the discrete distributions, and we don't use the density with the continuous distribution because it's going to give you how tall the curve is at that point, which most of the 99% of the time you don't care about. We are not using it. We can use it in other courses that deals with probability, but not in a regular probability course. So there are 4 functions. Okay, I didn't show you the fourth, but 4 functions. The discrete uses three of them, and the continuous uses three of them. Everybody uses the P, and everybody uses the last one I'm going to introduce. The discrete use the D, and the continuous use the Q. The last one is R for random. So if I want to create random variable from a binomial distribution, and let's say I'm going to type, I want to create 3, and the size is 10. I want three values, okay? I want three values from a binomial distribution where the size is 10 and the probability of success, let's leave it at 0.5. What does that mean? It means that notice that both the head and the tail have a probability of 0.5. So you can talk about heads or about tails. And I say, okay, so toss a coin 10 times and give me how many heads you get. And then toss it again, and then toss it again. And give me how many heads did you find in all three simulations. So that's a simulation, okay? I'm going to toss a coin 10 times. I got 4 heads, so I write 4. And then I toss 10 times again. I got 5, so write 5. And then I toss it 10 times again. I get 7, so I write 7. Okay? So that would be just continuous. I get 8, 6, 5. So that would be a simulation. I just, instead of tossing a coin 30 times, 10 I write, 10 I write, 10 I write, how many heads or how many tails for that matter, the computer does it in a second. These are the 4 things. Notice we are going to use either the normal distribution or the t distribution. So the t distribution is so easy. It's just t. So for example, suppose I want to find the 95th percentile of the t. Okay, so I have a t distribution and I want to find the 95th percentile, which we call t alpha of zero point 0.5 to t 0.5 and degrees of freedom. So suppose my n was 8 and I want to find the 95th percentile, the upper, like in a, if I'm running a hypothesis testing, I want to know what is the critical value. Okay, I would say QT. Yes, you are a QT person. Okay, QT. It asks me what percentile you want. I say 0.95, right? Because this means 95% of the distribution is to the left to the number I want. It asks me how many degrees of freedom. So whatever. Suppose n is 8, so I enter 7, n minus 1. Um, and okay. So now when I run this, I get 1.89. Notice that if that was a normal distribution, I get 1.645, and I expected the t will be larger than that. So I think this is the mere minimum that we need, okay? I'm going to use that now to solve one of the problems in next session. One of the problems we did already, you remember when we had 9 values and we wanted to see whether that mu is 107 or different from that, something like that. You did that in the previous session. So I wrote down the same numbers. I will enter them next time. And until then, I wish you all the best. I see you soon. Bye. Oh, I'm sorry. I should stop the